Today, I'm going to show you how you can do a volumetric survey on a stockpile or a hill using a drone. Now in a previous video, I showed you guys how I surveyed this hill using a surveying total station. By traversing around 4 different control points, we observed single observations on the stockpile hill and developed a digital surface model that we then computed the volume of the hill. But today I'm going to show you how much simpler and efficient it is to use a drone. Surveying with either a drone or a total station is really quite similar. Both require a control network, both require you to create two surfaces, and both of them will yield you relatively similar data. However, the amount of work that goes into the field is really what differs. Now the first thing we're going to want to do is set up a control network around the stockpile hill. Now since we surveyed this with the total station, I can just replace all of those points with targets. Now if you don't have a total station, you could use a GNSS receiver to observe all those points. That's completely fine, no problem. I also did set one point all the way at the top of the hill just to help us with processing the data, so now we have a total of 5 ground control points. And now that our control network is set up, it's time to bring out the drone. Okay, now as I'm setting this drone up, I want to answer a very important question. I'm sure some of you are wondering if using ground control points is necessary. And the short answer is no, it's not. Technically, you could do volumetric surveying without using ground control points because you're only taking relative measurements and finding the volume of material. Now, as a surveyor, though, I'm going to highly encourage you to use ground control points because it's just another method of ground truthing that you can use in order to ensure that your data is the most accurate. But in a process like this, it's technically not required. But good practice, so make sure you still do it. Okay, drone is all set up. Let's head back over to the hill.
Start operation.
There he goes, collecting data for our volumetric survey. Here's the path that the drone is taking. As you can see, he's going back and forth. When we look at the live view, look at that, we're already a quarter of the way there. Very nice, very good. You can actually see where that ground control point just was where we passed. So, nice clear imagery. Alright, there he is, finishing it up.
Operation complete.
Alright, and now the drone is coming back. Very nice. I like that. Alright, so now we're going to head into the office and process all the images that were captured by this drone in order to do our volumetric measurements. Hello and welcome to the office. Today we're going to be using Carlson photo capture powered by PixElement to perform our volumetric calculations on our hill. Once you open up photo capture, you're going to start by putting in the name of your project. I'm going to go ahead and name this project Drone Volume of Hill. Volume of Hill. Now for the output measurement, I live in Michigan and our units of measurement are international feet, so I'll go ahead and select international feet. There we go. Next, the output coordinate system, and this isn't really that crucial. The reason is that we don't really care where our project is located. When we did the volumetric survey with our total station, we actually created our own local system. The most important thing for this project is that we have the proper quantity measured. So for this instance, I'm going to go ahead and just use stapling coordinates, but it really doesn't matter what kind of coordinates I use. So Michigan South, NED83, go ahead and use that. And now we can import our images. Here are all the images. I'm going to just simply select all of them and drag them into the software. And we can also drag in our control points so that we can georeference them to the images. And I'm going to come down here where it says add ground control points. I will select that. I have a text file. My formatting is northing easting. My units of measurement are international feet. And when it asks for the coordinate system, it's going to be the same Michigan South coordinate system. I'll then browse, and I see my file right here, so I will open it. And there we go, the points are now in. I want them all to be GCPs. If I have some additional points that I wanted to make them checkpoints, I could just check off the checkpoint, but I'm just going to stick to ground control points. So then I'll hit finalize. Now it's asking if I can see the points. I can, so I will say yes. And now with all the data in, we can start with our initial processing. I'll select create. I'll validate that everything looks good here, and then I will create my project. And now I'll just let the image pre-processing run its course.
A few moments later.
Alright, now that the image pre-processing is complete, the bundle adjustment has started and it's gotten to 75%. At 75%, we are now required to add in the corrections for our reference points. So it says here, reference points ready for correction, and we can click on correct reference points. And this right here is just the general tie points, as well as our reference point manager. I'll expand this screen. And now all I have to do is reference the center of each target for every point in this project. So here, point number 1, I've gotten every single center. Point number 2, same thing. This right here is point number 3, point number 4, and last but not least, point number 5. Once I've georeferenced all of the control points, I can come down here to the bottom right where it says Process Project, and that will then allow the rest of the processing to take place, generating our outputs. So I'll come back when the outputs are ready.
One eternity later.
Alright, and the processing has now been completed and we have our outputs for our project. So you can view all of these individual outputs, but Photo Capture will combine several outputs and give you different tools that you can use for your advantage. So the first one we're going to look at is the Processing Analyzer, and this is really good to check and see the accuracy of your project. So if you come down to the bottom left, you can see the relative error for all of the ground control points, and I'm pretty impressed because all of these points are within 0.05 of a foot, which is completely acceptable. Having this marginal error ensures that we have an accurate data set. Now we're going to go into the survey canvas, and if you remember in a previous video, I showed you the feature extractions that you can do on the survey canvas, allowing you to show different types of features on different layers and exporting it out to a different software. Today I'm going to be showing you more of the surface creation and volumetric measurement tools that are in the survey canvas. So I'll go ahead and switch over to Survey Canvas. And here we have the generated point cloud. And as you can see, the 3D reconstruction was very good. We've got a nice hill that is generated from those images. So I'm feeling very confident that we're going to be able to extract the data that we need for our volumetric measurements. Alright, so now I want to generate a digital elevation model, or a DEM. This will allow us to simplify our point cloud so that we're not working with millions of points. While we could generate surfaces from the point cloud, working with so much data is going to make the process so much longer, more complicated, and probably crash my computer. So by simplifying the point cloud for millions of points, I can drop it down to a couple hundred points, and I can still generate a very accurate model of our surface. So what I'm going to do is I'm going to come over here to the right, and I'm going to select the Generate Grid tool. And as you can see here, we can change the intervals for X and Y, and I'm going to go ahead and change them to 5 feet apart. So every 5 feet will have a point. Now I can zoom in here, and I'm going to start to select points that are at the base of our hill. And I want to make sure I get the base points as much as possible because this is what's going to allow us to generate an accurate base surface. Come around here, just rotating to make sure I actually get the base. Okay, and now I will close this out, and as you can see, I am now generating the grid points. And if I zoom in here, I can see all of the red plus signs, and these are all the individual points that are spaced 5 feet apart, and that is going to be our grid that we're going to be able to use to generate our volumetric measurements. Now from this grid, I'm going to go ahead and select it and come down here to generate tin. What this will do is it'll connect all of the points and create a triangular irregular network, or tin, of the points. A tin is what is going to be used in order to create a surface. So we'll generate our tin, and now it's going to be triangulating. And there we go. I can zoom in here and you can see all the lines creating all these little triangles for our project. Now to help you visualize the tin, I'm going to come down here to the dense and surface options, and I'm going to toggle these off. So now you can see the triangulation of the hill. It's like a wireframe, and if I rotate around here, you can definitely make out where the elevation changes and how we can see like the skeleton version of the hill. I'll go ahead and toggle these back on so everything fits back together. So I'm going to go ahead and select this tin. I'm going to come down here to generate volume. This is what's going to allow us to generate our volumetric measurements. I'll select generate volume, and now I have the option to auto-generate my base tin. This is really, really powerful, and I love Photo Capture for being able to do this. What they do is they take the outside points of your tin and generate the base tin underneath of it, which allows them to take the differences of both surfaces to calculate the volume. So I'm going to select auto-generate tin, and there we go. It's generating the volume, And now we have a volumetric measurement of our stockpile. And the volumetric quantity that was calculated was 234,465.17 cubic feet. So I want to convert this over to cubic yards. So this is going to be 8,683.90 cubic yards. And the total station, we got 8,660.71 cubic yards. So what I'm going to do is take the quantity from the drone, which was 8683.90, subtract it from the total station, which was 8660.71, and I get a difference of 23.19 cubic yards. Divide that by our total station measurement, 8660.71, and I then have this decimal. I will then multiply that by 100, and with that we get an error of about 0.3%. And with 0.3% error, I can confidently say that a drone is an accurate piece of equipment that can be used to do a volumetric survey. I hope you guys enjoyed today's video. If you did, be sure to like and subscribe. If you're looking to learn more about total stations and how to use them in surveying, then check out this playlist up here. If you want to learn more about drones and how to use drones in surveying, then check out this playlist down here.